Hello students, I am Ravi sir, Faculty of Production Subject in ACE Engineering Academy. In the today's session, I will tell you how to prepare my subject production subject and some important question analysis you have to see for the exam TS GENCO-AE. Okay. Now see here, just see the topics on which I am going to speak here. You can see the number of topics. The 7 topics are there: casting, welding, non-traditional machining method, advanced machining method means NC CNC machine, then computer integrated manufacturing, next is metal cutting, machining and metrology. The number of important questions we have to see in the today's session. Okay. Now just first see the preparation strategy, how to prepare, then how many hours you have to study, and some question from where you can take the question for the study purpose. Now see, you can see the timetable from morning 5 to 8 a.m. 3 hours you can study, then 8 to 9 you can give your time for breakfast, and 9 to 1 p.m. also you can study for 4 hours. In the afternoon 1 to 2 time you can take for your lunch, as well as 15 to 20 minutes or maximum 30 minutes of sleep. Then again you can start study at 2 p.m. to 5 p.m. and 5 to 6 you can also take your tea and that all, and evening 6 to 8 or 6 to 9 also you can study here 2 to 3 hours. Then easily in a whole day you can study for 12 hours. Whatever day is remaining for your study, then you can study whole day for 12 hours. This is very easy timetable for us. But you need to fix your timetable. One day you are studying at night up to 12, 1, 2, and one day you are sleeping at 10. Then your body will not allow. There may be some schedule you need to give to your body. Then the body, our health can support us. Okay. Now see question bank, from where you can get the question for this preparation guides. What is the question? Any books are available, all previous year question, SSC, JEE, then TSPSC, APPSC or other state exam questions also you can take for your preparation. You can read that question, and that practice will help you in the exam, as well as most important questions, that is the gate questions, 1 mark gate question or 2 mark also, but theory gate questions. Okay. Some 2 marks match the pair format questions are also available for gate. That all questions are important, and as well as ESC questions are also there. And you can't think only the easy questions will come in the exam. Some tough question will also come in the exam, and that tough question only help you to crack this exam. Okay, that's why you also go with the gate 1 mark question or 2 mark match the pair questions, as well as ESC prelim questions you can see for your preparation, and definitely some questions will repeat. And also whatever the questions are available, same question may not be repeat, but the same point they will ask in the exam, same concept they will ask in the exam. Okay, now see the syllabus of that. All production subject, as you know, the production subject is highest weighted subject for your exam also. The many number of questions, more than 50 questions, 15 questions, 15 will be from production subject. Okay, then you can see the casting, forming and joining process, but already here the forming lecture is completed, forming and sheet metal lecture is completed already. Then today the casting and joining process, joining means it is welding. Okay. Then you can see here the plastic deformation, yield stress, yield criteria, fundamentals of hot and cold working process, load estimation for bulk, forging, rolling, extrusion, drawing and sheet, shearing, dip drawing, bending, metal forming process. That all is, that session is already completed. Production, that is by our Madhushekar sir, he completed that metal forming and sheet metal chapter, and the principles of powder metallurgy also he completed. That is the material science subject, and remaining you can see that up to here they given the syllabus of casting, and then from here to here they given the syllabus of welding. You can see the welding syllabus also, welding, brazing, soldering and adhesive bonding. The syllabus is mentioned in short words, but it is very big, it is not small syllabus. Next is machining and machine tool operation, means it is all related to metal cutting or the lathe machines, and in that also they given the non-traditional machining process. Okay. then principle of work holding, jigs and fixture, abrasive machining process, NC, CNC machines and CNC programming, that all the questions of this part we are going to see today's lecture. And also metrology and inspection, and next the computer integrated manufacturing. That computer integrated manufacturing I am going to cover in advanced machining method chapter, that is NC, CNC machines chapter. I am going to cover that computer integrated manufacturing also. Okay. Now see the first question without wasting time, and here you can give the answer. Okay, I can see your answer also. Try to give the answer. Okay, now see here, first question of casting chapter. In expendable mold and expendable pattern, in which casting the expendable mold and expendable patterns are used? Expendable mold and expendable pattern are used. You can give the answer here, guys. Okay. Now see, the expendable mold means the mold which are going to break the mold. Then definitely, guys, the sand mold is there, means the mold which is made by molding sand, that mold we are going to break and we are taking the casted component. Then all the sand molds are expendable mold. And next, the expendable pattern. Expendable pattern means pattern also we are going to break. In the sand casting, just see, if we have one pattern here in the sand casting, one wood pattern we have, or one metal pattern we have, that aluminum metal pattern we can use, the cast iron metal pattern we can use, or white metal also we can use for a pattern. Means the all pattern must has light weight. Okay, that metal pattern also we can use, or wood pattern also we can use. Now that pattern we are not going to break in a sand molding. Hence the sand molding process is only expendable mold process. In the sand molding we are going to break only the mold, but not pattern. But guys, there is one method which is very famous method, that is investment casting, and in that investment casting we are going to break the mold as well as pattern. How we are breaking that pattern? Guys, there is one metal die, and by using metal die we are going to make the number of patterns. Okay, in the metal die we are making number of patterns we are making. Then guys, that all patterns are attached to one of the sprue, and by using that pattern we are going to make the mold. And when we made that mold, then we are inverting that mold and we are giving the heat, then that solid wax will convert into liquid wax, and liquid wax will leave the cavity, will go out of cavity. Okay, then the pattern, here is the wax pattern, guys, and that wax pattern is going to break here. Wax pattern is going to break, hence it is known as expendable pattern process. Whatever the castings are available, then guys, out of that all casting, only the investment casting has both expendable mold and expendable pattern. Now the wax we melted means we broken that wax. We melted means broken, and we taken out that wax. And what is that expendable mold? What is that expendable mold? Guys, the expendable mold means we remove that liquid wax, we pour that molten metal into that, and when that molten metal will convert into solid, then by breaking that mold we are taking the casted component. It means that we are going to break the mold also in investment casting. Hence in the correct answer, in investment casting, expendable mold and expendable pattern are used. Okay. In the shell mold casting, guys, it is only expendable mold process, only the mold we are going to break in the shell mold. And in the slush casting also, if sand mold we are making in the slush casting, then also it is the expendable mold process. Or if the metal mold we are going to use in the slush casting, nowadays the metal mold we are using, then it is not expendable mold, because metal mold we are not going to break. And in the die casting also, the metal mold we are going to use. In die casting also, the metal mold we are going to use, and we are not breaking that metal mold. Then here these two processes are not expendable mold process also, but the shell mold casting is expendable mold process, and the investment casting is expendable mold as well as expendable pattern process. Okay. Now see the question 2. In a metal casting, the solidification of molten metal ends at. Very interesting question. I am going to revise your many basic and important points of this chapter. Just see the solidification. For the solidification, you can observe this diagram. Guys, here we are going to pour that molten metal. This is the pouring temperature. This is the freezing temperature and this is the room temperature. This is the room temperature. Pouring temperature means here liquid we are going to pour, guys, and here also we will get the liquid only, but here we will get solid. And here the from this point to this point means here you can see that the time is known as solidification time, that is denoted by tau. Then guys, tell me where the solidification is going to start. The solidification is going to start at this point. Okay, and at this point I am writing the A, here I am writing the B, here I am writing the C, here I am writing D. And at A point here the solidification is started, and at C point the solidification is going to end. The C point is what? Freezing temperature as a solid. C point is what? Freezing temperature as a solid. What the question? In metal casting, the solidification of molten metal ends at freezing temperature as a solid. Okay. What is the pouring temperature? Pouring temperature means this temperature is the pouring temperature. At the pouring temperature, the solidification starts. If they are asking in metal casting, the solidification of molten metal starts at, then we can give the answer pouring temperature. Okay. Then after pouring temperature, you can see this point is freezing temperature as a liquid, and the solidification is going to end here, and this point is known as freezing temperature as a solid, where the solidification is going to end. After C point, when the solidification is completed here, then just take the mold along with the casting and put on vibration mesh and give the vibrational forces like that, and the mold is going to break and we can take the casted component. Hence this is, guys, the stage 1 and stage 2. The stage 1 and stage 2 is going to happen inside the cavity, inside the mold, and stage 3 is going to happen outside the mold, because at the stage 3 we are going to break that mold. Okay. Then here the room temperature is also not correct, because the room temperature is the last point. You can see this point is room temperature. Then correct answer is option C, freezing temperature as a solid. Yes, more intricate casting geometries are possible with, guys, you are buying the gold ornaments, you are buying the gold ornaments, and just ask in that shop which method you are using. I don't think so they will tell directly we are using the investment casting, but they will say that we need the wax to make that gold ornaments or silver ornaments. Okay. Then guys, they are using the investment casting, and how the gold and silver ornaments, you can see that how the critical shapes are there, and hence then more intricate casting geometries are possible with just see, it is possible with the semi-permanent mold. Okay, semi-permanent mold. And semi-permanent mold means it is known as investment casting. It is known as investment casting. Investment casting. Yes, it is known as investment casting. The semi-permanent mold we are telling in the investment casting, because in the investment casting in one mold we can get the 5-6 component, 10, 20, 30, 50, up to 100 components also we can obtain in one mold. But in the expendable mold is the sand mold, one mold, one component, one mold, one component. In the permanent mold, one mold, number of components, thousands of components, 1,000, 2,000, 5,000, 10,000. Hence the metal mold are known as permanent mold. And semi-permanent means what? In one mold 5, 10, 20, 50, up to 100 components. Hence the investment casting is also known as semi-permanent mold casting process. And the investment casting we can get the critical shaped components. Hence the more intricate casting geometries are possible with the investment casting, but the name is given semi-permanent mold. The correct option is option C. Yes, guys, this is very interesting question, guys. Okay. Then you read that question and try to give the answer here. I am going to wait here. Yes. Now see here, you can see the solution here. Factors affecting the fluidity of molten metal in the casting. The fluidity means what is meant by fluids which can flow. What is meant by fluids which can flow? What is going to flow? The water is going to flow, the air is going to flow, and the water has the fluidity, the air has fluidity. The molten metal means liquid metal also has some fluidity. Okay, then the factor affecting the fluidity of molten metal in the casting. Now see which factors are there for the fluidity. Just see the pouring temperature. We are writing, guys, the PT, pouring temperature, is equal to melting point temperature of material plus degree of superheat, or only we are writing here the superheat. Then I am writing here the degree of superheat. Degree of superheat. Here I am writing the degree of superheat. Then here the melting point temperature, if we are going to take the melting point temperature for air, then it is 1539 plus 150 to 200 degrees centigrade. 150 to 200 degrees centigrade. If we are increasing the degree of superheat, now guys, then pouring temperature is also going to increase. Just see, if we are increasing the degree of superheat, then pouring temperature is also going to increase, and the fluidity of molten metal is going to increase. Hence the first option is correct. Next is viscosity of liquid metal. Guys, as the temperature is going to increase, then viscosity of molten metal is going to reduce, and it can flow with the high velocity. If the molten metal or liquid is going to flow with the high velocity, then it has good fluidity. And in the fluid mechanics, we have the formula, the chow is equal to mu into du by dy. What is that du? Du is the velocity. Then I can write here the du is equal to tau into dy divided by mu. Okay. Then guys, as the viscosity is going to, here you can see that if viscosity is going to reduce, velocity is going to increase, and velocity is going to increase, means I can write the velocity is directly proportional to the fluidity. Directly proportional to the fluidity. Then if the viscosity of liquid metal means the fluidity, the factors affecting the fluidity of molten metal, it is also depend on the viscosity, because as the viscosity is going to reduce, but how the viscosity can reduce? If the degree of superheat is going to increase, then it will be the less viscous, and that liquid metal can travel very fast. Then option B is also correct. Okay, the option C, heat transfer to the surrounding. Guys, if the heat transfer to the surrounding means what? We started pouring the molten metal into the pouring basin, then it is going to enter into the sprue, runner, ingot and casting cavity. When it is entering and when it is entered, the heat is going to transfer. And just see, if we are doing the casting in atmosphere where the atmospheric temperature is negative, minus 10 degrees centigrade, minus 20 degrees centigrade, we are doing the casting. And some other places also we are doing the casting where the atmospheric temperature is 30 degrees centigrade, where the heat transfer will be more. In the first case, the heat transfer will be more, and in the second case, the heat transfer will be less. And if the heat transfer is very fast, then viscosity of molten metal is going to increase, then the fluidity is going to reduce. Hence, the option C is also correct. Therefore, I can write the correct answer as the all the above. I can write here the all the above. All options are right. Now see the next question. Riser must solidify. Okay. Guys, there is one important formula we are using. The solidification of molten metal in the riser is solidification tau r, means it is the solidification time of molten metal in the riser must be greater than or equal to solidification or time of molten metal in the casting cavity. Okay. Then guys, then we can write the solidification time of molten metal in the riser is must be greater than or equal to solidification time of molten metal in the casting cavity. Then here which answer is correct? Riser must solidify after the casting solidifies. Okay. Means just see, if the casting is going to solidify in 100 seconds, then riser need to solidify more than 100 seconds. I am taking 120 seconds. Then first the molten metal in the casting cavity is going to solidify, and after then molten metal is going to solidify. Then riser must solidify after the casting solidifies. But guys, second option is also there. If this option is not available, then here you can see that here the 2 points are there. One is tau r is greater than tau c, and second here equal to, also you can see that tau r is equal to tau c. Then solidification time of molten metal in the riser is equal to solidification time of molten metal in the casting, and that option is also available at the same time of casting. At the same time of casting, that option is also available. Guys, now this option is also available, but if it is a multiple select question, we can choose the two options, then we can choose the B and C. But it is not a multiple select question, we have to give only one answer, then correct answer is B. And if the B option is not available, then we can go with the option C also. Okay, yes, this question is completed. Okay, now see the next question. Guys, in your exam, the casting defects is also very important, the welding defects are also very important. Now see, when two portions of the metal flow together, but there is a lack of fusion between them, just see some molten metal is going to enter. Just see the molten metal is entering from here, and at the same time the molten metal is also entering from here. Guys, that both molten metal need to fuse. That molten metal need to fuse properly. Means this molten metal must enter into this molten metal. And that left side molten metal must enter into right side molten metal, means it is proper fusion is there. But if the proper fusion is not there, means the left hand side, this left side molten metal is not entering into right side molten metal, and right side molten metal is not entering to left side molten metal, then what happens? Then one defect is going to form, and that defect is known as cold shut. That defect is known as cold shut. Guys, that defect is cold shut is there. Okay, then how we can avoid that cold shut? We can increase the degree of superheat. Here we discussed the formula about the degree of superheat. If we are going to increase the degree of superheat, then we can avoid this defect. Okay, now that casting questions are completed, now I am going to start with the welding questions here. Okay, I am going to start with the welding questions here. Yes. Yes. The first question here, actually this is revision also. This is giving very good revision. In 1 hour you will get the revision of number of chapters here. That is good thing of this lecture. And also you are getting the number of questions here in a short span in 1 hour. It is very good practice for you. Now see, which of the following is the non-fusion welding process? Which of the following is the non-fusion welding process? Guys, here you can see, here the spot welding, projection welding, resistance seam welding and percussion welding. Here you can see that all four are the resistance welding. All four are the resistance welding. All four are the resistance welding, guys. And just see the all four are resistance welding methods. Then resistance welding is fusion welding process. Resistance welding is fusion welding process. Then is this correct or wrong question? Resistance welding is fusion welding process. Then is this correct or wrong question? Yes, then guys, this is the correct question. These are 4 methods of resistance welding, and out of that 4 method, there is one method, that is the percussion welding, or also it is known as flash butt welding. Flash butt welding. Also known as flash butt welding. This option D is correct. This is one of the resistance welding where it is non-fusion welding. Resistance welding is fusion welding, and that all ABC methods are the fusion welding. Fusion welding means by melting the parent material, means if the base metal is going to melt, then it is known as fusion welding. But here the base metal is not going to melt, it is known as non-fusion welding. And guys, these all are the lap welding. These all are the lap welding, and here you can see that the percussion welding is the butt welding. This is the one shaft and this is the second shaft. We are going to join shaft 1 and shaft 2, and this is known as butt welding. But other weldings are, you can see that other weldings are the lap welding. Okay. Now this question is completed. Now see the next question. The temperature in the process is below the melting point of metal being welded. Oh, the temperature in the process is below the melting point of metals being welded, means it is the case of non-fusion welding where no filler metal is utilized, called as. Guys, here the temperature in the process is below the melting point of metal being welded. Means the temperature is lesser than melting point temperature, then it is a non-fusion welding. And we know that the resistance welding is the fusion welding. Thermite welding is the fusion welding. Then brazing and solid state welding are non-fusion welding. Then which is the correct answer? But here you can see that where no filler metal is utilized or where no filler metal is used, guys, in the brazing we require the filler metal. In brazing we require the filler metal. In brazing we require filler metal. Okay, then in solid state welding we are not going to use the filler metal. But what is correct answer? Where no filler metal is utilized. If it is given where the filler metal is utilized, then I can give the answer brazing. But where no filler metal is utilized, then correct answer is solid state welding. In the solid state welding, the melting point temperature, the temperature developed in that components in the joining plate is lesser than melting point temperature. Okay, but the filler rod is not used or filler metal is not used in solid state welding, but it is used in brazing. And the correct answer is option C. Next, CO2 as an inert gas used in. Guys, in the arc welding, some interesting methods are there which is commonly used in industry. The one is TIG, that is a tungsten inert gas welding, and second is metal inert gas welding. Are the inert gases, this is the TIG means tungsten inert gas, I stand for inert gas, and here the MIG, this I stand for inert gas. Tungsten inert gas welding, metal inert gas welding, then which inert gases are commonly used here? In the both method we can use the argon or helium used as inert gas in both method, or sometimes the mixture is also used. But guys, if you are asking to one of the engineer who is working more than 10 years in the industry, then he will tell you about the argon only. He don't know about the helium. Because in very, means only few industry, few MNCs, they are going to use the helium. But we can use the argon or helium or the mixture of two also we can use. But in the MIG additionally, we can use the carbon dioxide also, the inert gas. Hence CO2 as inert gas used in MIG. Okay, in the MIG sometime the carbon dioxide also we are going to use the inert gas. Guys, but that CO2 is not possible to use in the TIG method. Okay, why it is not possible? Because there is one method of metal transfer. Method of metal transfer in the MIG, that is the short circuiting. You see, just see if here is the molten metal, then the tip of tool is touching here and supplying. Just see here some small drop of molten metal is developed. Then that small drop of molten metal, we need to push it down that tool. Then that small drop of molten metal will touch to that weld pool here and it will supply the molten metal. And here we can use here the CO2 as the inert gas. CO2 is heavy gas, therefore it settles at the down, and in the MIG short circuiting metal transfer, the distance between the tip of tool and workpiece is very small. If the distance is very big, then we cannot use the carbon dioxide. The distance is big in the TIG method. Then in the TIG method you can see that electrode will be up to here. Then here arc length is more in the TIG. And if the carbon dioxide is going to settle up to here, then how it can cover that electrode. It is not going to cover. Then here the correct answer, guys. Correct answer is MEG. Yes, MEG is the correct answer. Now, next question is a group of fusion welding process that uses a combination of heat and pressure. Resistance welding. Guys, in the resistance welding, the high pressure we are giving to join that two sheets. Mostly the resistance welding is used for joining the sheets. Here the sheets are there, and I am going to show the electrodes also. Yes. Now see, the two electrodes are giving very high pressure, and then it is giving the heat is also, the heat is going to generate here where we have to join. Then in the resistance welding, the both things are there, the heat is also there and the pressure is also there. Okay, next gas welding. In the gas welding, only the heat we are giving, pressure we are not giving. In the arc welding also, only heat we are giving and the pressure also we are giving. Okay, and in the solid state welding also, some methods are there where we are giving the pressure. Then again read the question. This is a group of fusion welding process that uses a combination of heat and pressure. They are asking about the fusion welding, and resistance welding is fusion welding and solid state welding is the non-fusion welding. But in the solid state welding also, in some methods, the heat as well as pressure is going to apply. But here they clearly mention the fusion welding, and solid state welding is non-fusion welding, hence correct option is option A. Next question is a joining process in which filler metal is melted and distributed by capillary action between the faying surface of the metal part being joined. Capillary action between the faying surface is what is meaning of this faying surface. Faying surfaces means joining surfaces. Faying surfaces means joining surfaces. Faying surfaces means joining surfaces. Okay, then between the faying surface. Then here what is the capillary action? Capillary action means molten metal can enter through a small spaces. Guys, out of that all welding, you can see that the brazing is the method. This brazing is the method in which we can repair the cracks. Means if the cracks are present, in that crack we can pour that drop of molten metal, and the crack means very small space is there, but from that small space also the molten metal can enter. Means that molten metal must have high capillary action or high capillarity also we can say. Then brazing is a joining process in which a filler metal is melted and distributed by capillary action. Guys, here braze welding also the filler rod is required, but capillary action is not required because the braze welding is used for joining the two pipes. And in the soldering also we require the filler rod, but simple to join the two components we are using the soldering. Means the brazing we are using for repairing the cracks, and to repair the cracks that molten metal need to enter through a very small spaces, then that molten metal must has high capillary action. Yes, next, which of the following welding is automated? Oh, you see, very interesting question here. Which of the following welding is automated? The 100% automation, it is very difficult to implement. Even though in the India also, many companies are there, many MNCs are there, where the 100% automation is not possible. 100% automation means robot is required or robo arm is required. But here out of that all method, the wonderful method is metal inert gas welding, where we can use the automation. Okay. Then metal inert gas welding is the correct answer. Next you can see that the shielded metal arc welding. Guys, the shielded metal arc welding is very old process, and in that process the shielded metal means electrode is shielded. Electrode is shielded, and it is very old method. It is done by one welder only, by human being it is done. but the MIG, the semi-automation is possible. Semi-automatic method is there. The MIG is semi-automatic method is there. Okay. Then guys, next is submerged gas welding. The gas welding is not automated, hence these both options are not there. Okay. Then here the metal inert gas welding is automated, means semi-automatic machine. We can say it is the semi-automatic machine. And here again you cannot see the one option, submerged arc welding. Submerged arc welding. Submerged arc welding is also semi-automatic method. Submerged arc welding. SUBMERGED, submerged arc welding. Submerged arc welding. Okay, in the submerged arc welding, also it is also the semi-automatic method. It is also semi-automatic, means both methods are there which are semi-automatic, that is a metal inert gas and submerged arc welding. Yes. Now see the questions of non-traditional machining method chapter. Which of the following is mechanical energy process? Now see in the NTMM chapter, non-traditional machining method chapter, some mechanical energy methods are there. And in that mechanical energy method, the first method is USM, ultrasonic machining method. This is the first method. The second method is water jet machining method. Third method is abrasive water jet machining method, AWJM. And fourth method is abrasive jet machining method. Now out of that all, here you can see only option D is water jet machining, WJM. Means one nozzle is there. In that nozzle we are putting the water and we are pressurizing that water, and it is water jet machining. Now what is abrasive water jet machining? If in the water, if we are putting the abrasives, then it is abrasive water jet machining. What is the AJM, abrasive jet machining? Air plus abrasive is known as abrasive jet machining. And the correct answer is water jet machining. Okay, here you can see the EDM, electric discharge machining, and electron beam machining. These are the thermal energy process. This is the example of thermal energy process. Thermal energy process. Okay, the mechanical energy processes are those. The thermal energy is electric discharge machining, electron beam machining, and laser beam machining is the example of thermal energy process. And electrochemical grinding means these are the electrochemical machining process. Electrochemical energy process. Electrochemical energy process. It is a electrochemical grinding. That is the electrochemical machining as well as electrochemical grinding. These two are the electrochemical energy process. Electrochemical means electrical energy in a combination of chemical reaction used for machining process. Yes, in EDM the workpiece and electrode are separated by a gap. Okay. Now see in the EDM method, the workpiece and electrode are separated by a gap called as spark gap, which is generally, okay, what will be the spark gap? If you are here, then you can answer me. They are asking the question about EDM. Okay. Now see here that gap is 0.20 to 0.5 millimeter is the gap in the EDM method. Now see which of the following statement is correct for unconventional machining process. Which of the following statement is correct for unconventional machining process? Guys, unconventional means non-traditional machining methods, NTMM. What is meant by non-traditional machining method? There is no contact between the tool and workpiece. Then is there any option? The tool is never contact with the job. Tool is never contact with the job means tool is never contact with the workpiece. That is correct option. Then which of the following statement is correct for unconventional machining process? It is a correct statement. Tool is never contact with job. Okay. Then just see we have the other option also. The tool material is harder than workpiece material. The tool material is harder than workpiece material. It is correct, but not for non-traditional machining method. It is correct for conventional machining methods. What are the machines you are going to see in your college workshop? That is the lathe machine, drilling machine, milling machine, slotting machine. In all that machine, the tool must be harder than workpiece. It is correct for only conventional. It is not correct for unconventional. Tool is in contact with the job. Okay. At all machines, lathe machine, shaping machine, drilling machine, milling machine, in all that machines, the tool is in contact with job. Next, tool is never contact with job. Okay. The relative motion between the tool and job. Actually, the relative motion between the tool and job is also here. Just see in EDM it is there. In the ECM also it is there. But in not all methods. It's correct option. The tool is never contact with job. Next, conducting tool and conducting workpiece is required in. Conducting tool and conducting workpiece. Guys, out of all non-traditional machining methods, the two methods are there. One is EDM. And second is ECM. Electric discharge machining method and electrochemical machining method. In that both method we require the conducting tool as well as conducting workpiece. Okay. But in other method, the conducting tool as well as conducting workpiece is not required. Means out of how many? 7 non-traditional machining methods are there, and out of that total 7, these 2 is not required. These 2 is required, conducting tool and conducting workpiece. In other method it is not required. And out of that you can see here the option D, electric discharge machining. Here the conducting tool and conducting workpiece is required. Next is laser beam machining. In that laser beam machining it is not required. Electron beam machining, ultrasonic machining it is not required. Correct option is option D. Yes, now see the question of AMM chapter, that is advanced machining method, and also the computer integrated manufacturing. Now the G02 represents the following instruction in CNC programming. Guys, the G00 means no cutting action is going on. Only the tool is moving very fast without removing any material. And the G01 means tool is traveling in the straight line path with cutting some material. G02, tool is cutting the material in a clockwise direction. Then you can see the circular interpolation clockwise is the correct answer. Here also you can see the option circular interpolation counterclockwise, but for that counterclockwise you can see the G03 is the option. Okay, then correct option guys, that is the option A. Circular interpolation clockwise, G02. If they are asking the G03, then circular interpolation counterclockwise. Okay, then acceleration and retardation is also not correct here. Next, technique which uses the computer controlled machineries and automation system in entire production process. Guys, what is meaning of computer integrated manufacturing? In that computer integrated manufacturing means it is a high level of automation, and in that computer integrated manufacturing we are throwing that human being. We are throwing that human being from machining zone. As total computerized control in the company is there, and that is known as computer integrated manufacturing. And then here the technique which uses computer controlled machineries and automation system in entire production process is known as CIM, computer integrated manufacturing. And here you can see that CAD, computer aided design, which you are making one model by using the software Unigraphics, CATIA, Solid Edge, SolidWorks, Pro-E, that software you are using, and you are going to make the model, that is CAD. CAM is CNC machines, computer aided manufacturing, means manufacturing with the help of computer, and CAE is computer aided engineering. Then in the CAE, we are going to do the analysis of the component. Analysis means by using ANSYS software. What you are doing by using the ANSYS software, that is the analysis. And this all three includes in the CAM. If someone is asking what terms, what parameters, what the concept, the computer integrated manufacturing is telling, it is going to add CAD plus CAM plus CAE, you can write. Yes, now see, it is a system that create a process plan. It's very high level concept, process plan for a new component automatically rather than using predefined standard plan. Means one standard plan is saved in the computer, but guys, just give the model to the machine, and by using that model, that computer will develop the program. Why to write the G codes, M codes in the program? No need to write, only give the model. According to model, that machine will work, and that is known as generative CAP. Generative CAP. What is mean by CAP? CAP is computer aided process planning. Means process planning, aid means help, with the help. Process planning, aid means help, with the help of computer. And the variant and retrieval is same thing. Variant and retrieval means here create a process plan for new component automatically. In the variant and retrieval, for a new component, automatically process plan they are not going to generate. But a generative means it is a generating new process plan automatically, hence it is known as generative CAP. Very interesting question here. Electric motor used for CNC machines. Electric motor used for CNC machines. Guys, just see. Nowadays, we are using the servo motors also. We are using the linear motors also. The linear motors also you can check on the YouTube. Some videos of linear motor you will get. Just see, the linear motors are used in high speed machines. Linear motors are used in high speed machines, and it is very accurate. Even though no need to use the lead screw and nut assembly, no need to use the preloaded ball screw, directly linear motors we can use for high speed CNC machines. Then the linear motors are recently, we are using that linear motor. Now the DC and AC, out of DC, the AC is most commonly used, the servo motors, because the maintenance cost for AC servo motor is very low as compared to DC. But initially we use the DC servo motor also, and for your exam the more numericals are not there, and if you know the numericals, then many numericals are available on the DC servo motor. Okay. Now AC also we used, DC also used, hence the correct answer is what? All the above is the correct answer. But guys, here the linear motor is not given. Instead of linear motors, the option is given induction motor. Here is given stepper motor and DC and AC. Then we have to select one. Just see, here is induction motor. Induction motor. And here is the stepper motor. Okay, induction motor and stepper motor and DC, AC, then which option you can choose? Instead of DC servo motor, AC servo motors are better. Then out of that all, we can go with the AC servo motor. Yes, now see the questions of metal cutting chapter, very interesting question. Cutting power consumption can be reduced by. How the cutting power consumptions, power means we are supplying the power to the lathe machine. On the lathe machine there is one motor, induction motor is there, and we are supplying power to that motor. And when the power consumption can be reduced, how we can reduce the power consumption? Okay. Then guys, if we are going to increase the back rake angle, now you can see that what is the back rake angle, you can see. Yes, you can see guys, this is the back rake angle here. From here to here, this is the back rake angle. Guys, if we are going to increase the back rake angle, You can see that if we are increasing, then here the material will be less, here the material will be less, and here the tip of tool will be sharp. Extreme sharp tip of tool is not there, but sharp as compared to other cases. Then here if you are going to increase the back rake angle, then the point, the tip of tool is there and tip of tool is going to make the contact with the workpiece, then that area, contacting area of tip of tool and workpiece will be less if you are going to increase the back rake angle. And if that area is, contacting area is less, then definitely the forces are less. And if the forces are less, the power consumption means electricity consumption is also less. Then here always better to reduce the power consumption, it is always better to increase the back rake angle. The same case increase in side rake angle, same case increase in relief angle. Hence here the correct answer is all the above is the correct answer. Very interesting question here, very interesting question. Now see the second question. When machining is carried out under dry machining condition, okay, what is mean by dry machining condition, guys? What is mean by dry machining condition? The dry machining condition means coolant we are not going to use, coolant or cutting fluid we can say, cutting fluid is not used. Cutting fluid we are not going to use. This is known as dry machining condition. Cutting fluid is not used. Cutting fluid is not used. The maximum heat generated during machining is carried away by, if we are using the cutting fluid, then cutting fluid is going to carry out that all the heat, but here the dry machining condition is there. Then guys, out of that chip, workpiece and tool, the chip is going to carry the maximum heat generated during machining. And guys, the chip is going to carry around, just see the chip is going to carry around 75% to 80% of heat is going to carried by chip. And guys, here the workpiece, you can see the workpiece is going to carry 15% to 20% of heat, and the tool is going to carry only 6% to 8% of heat. Hence the correct answer is option B, that is the chip. Okay, you also give the answer. I can see your answer here. Now next, built-up edge is formed while machining. Guys, when we are machining the brittle material, then the discontinuous chips are going to form, and when the discontinuous chips are going to form, then the built-up edge is not going to form. But they are asking the built-up edge is formed while machining. Now see, if you are machining the ductile material, then the built-up edge can form, but when we are machining with the ductile material with the high speed, then no time available for the chips to stick on the tool, stick on the tip of tool. Okay, and here the brittle material is option given, then built-up edge is not formed. Here is also brittle material, built-up edge is not formed. Ductile material with high speed, no time is available for the chips or some small particles of the chips to present. Here is the contact between the tip of tool and chip, and because of that contact the friction is there, heat is going to generate, and the particles of chip is going to stick on the tip of tool. But here the ductile material at high speed, if the high speed is there, then it is not possible to stick because no time available to stick that. Then definitely when there is ductile material is there, means continuous chips are going to form at low speed. If the chip is traveling on the rake face at the low speed, then that particles of that chip is going to stick on the rake face of the tool, and because of that, guys, the built-up edge is going to form. Built-up edge is going to form. Now see the next question. The hot hardness is property for. The hot hardness is the property for gear material? No. Guys, one topic is there, very simple question, the hot hardness of tool. Hot hardness of tool material. And directly the hot hardness is the property of tool material. It is not property of gear material, shaft material, welding material. The hot hardness term we are going to use for tool material. Means guys, what happens when the tool we are going to use, there is a continuous contact between the tip of tool and the workpiece, and the heat is going to generate on the tool, and the temperature of tool is going to increase, and at some temperature at some temperature the tool is started reducing its hardness, and that temperature is known as hot hardness temperature of that tool material. Okay, then here the correct hot hardness is the property of tool material. Yes, now see the next. In Taylor's tool life equation, that is Vt raised to n is equal to C. Very interesting. The value of n depends on, yes, value of n is depend on, is depend on work material? No. Types of chip? No. Heat produced? No. It is the value of n, that is the n is the constant, is depend on tool material. Okay? The Taylor's tool life equation, that small n constant is depend on tool material. Yes, now see the next question of the chapter here, the machining is the chapter. Okay. Now see the first question is very good question, you can see here. Trepanning is performed for, guys, if we have to produce very big hole, not blind, if we have to produce the through hole, then we can produce that hole without drilling. Means trepanning is specially operation, the trepanner tool, if you don't know what that tool, how that tool is working, how that tool is there, you can check on the Google, there is one trepanner tool, trepanning tool or trepanner tool, we can say that tool is specially used for producing a large hole without drilling. Without drilling we can produce the large hole, and that very famous method is trepanning. It is not used for finishing a drilled hole, it is not a rimming method, it is truing a hole for alignment, then enlarging a drill hole, no. Only option B is correct. Now see next. A good cutting fluid should have, oh, it is not easy question. Huh? A good cutting fluid should have. Now see, low thermal conductivity. Guys, the workpiece is continuously contact with the tool in the lathe machine also, in the CNC machine also. And in the CNC machine, lathe machine, directly when the operation is going on, we need to supply the cutting fluid. Cutting fluid means there are two types of cutting fluid, one is coolant or second is lubricant. In the cutting fluid we are going to use, then that cutting fluid must have high thermal conductivity. Thermal conductivity means that cutting fluid need to carry away that heat. That cutting fluid need to carry away that heat from that machining environment, then that cutting fluid must have high thermal conductivity, but here the option is low thermal conductivity, which is wrong. Okay. Now see the next, high specific heat. Guys, the specific heat is denoted by Cp and its unit is kilojoule per kg Kelvin or kg degree centigrade also we can use. Then you see, if one material has 100, value of Cp is 100, and the second material the value is 10, then which Cp value you will use? Then one value means Cp is 100, means 100 kilojoule energy is required to increase the 1 kilogram of fluid by 1 degree centigrade. Means to increase the temperature of that cutting fluid by 1 degree centigrade, 100 kilojoule energy is required. Means that if this first cutting fluid we are going to use, then 100 kilojoule energy is required to increase the temperature of that cutting fluid by 1 degree centigrade, then it is very good thing. It is very good thing. Means 100 kilojoule energy heat it can take, and only its increase in temperature is 1 degree centigrade. And in second case, only in a 10, means 10 kilojoule, if it is going to absorb the 10 kilojoule of heat, then its temperature is going to increase by 1 degree centigrade. Then which is better? First option is always better. Because in the second option, when it is giving the 100 kilojoule of heat, then this temperature of that cutting fluid is going to increase by 10 degrees centigrade. Temperature must be low. And the correct option is high specific heat. The next is high viscosity. If the high viscosity is there, then in the critical shape, critical points, that cutting fluid will not enter, and high density is also not correct. Correct option is high specific heat. And guys, that same concept we are going to use in the welding chapter also to tell the properties of non-consumable electrode. The same concept we are using here also. And also in non-traditional machining method, EDM chapter also, EDM topic also, electric discharge machining also, That same point we are going to discuss. Yes, most commonly used material for manufacturing of machine tool bed. Very famous question from many days, very famous question, and that answer is gray cast iron, which can absorb the vibrations while machining. Therefore, we are using the gray cast iron. Mild steel is not there, white cast iron is not there, galvanized iron is not there. This is very famous question, gray cast iron. And guys, this machine tool bed is also made by casting process. That is also very famous point. Now, rimming is mainly used for achieving, okay, higher MRR, no, because rimming we are going to do on already drilled hole, then here the high MRR is not there. Improved dimensional tolerance is the correct. Fine surface finish is also correct. Improved positional tolerance is also correct. But out of that all, the first priority I need to give for improved dimensional tolerance. Improved dimensional tolerance, we are using the rimming, but that through the rimming also we can get the surface finish also. We can get the good surface finish also through the rimming. Okay, and the correct option is option B is the first option. Option B is the correct. Now see, in the manufacturing of twist drill, the shank is joined to the body of drill using, again the welding is there. In the friction welding we are studying, why we are using the friction welding? To join the shank to the tip of tool or to the tool, we can say. There is one tool and to that tool we have to join one shank, then we can join by using friction welding. The spot welding, TIG, projection welding is not there. Correct answer is friction welding. Okay, now see the remaining question here, some metrology questions are there. Appropriate instrument to check flatness of slip gauges. Flatness of slip gauges. How to measure the flatness of slip gauge, guys? We can check by using optical interferometer. Option C is correct. Not dial indicator. Pneumatic comparator is not there. Tool maker microscope is also not there. Optical interferometer is the correct answer. Next, to fit the whole shaft pair system is specified as H7S6. Is specified as H7S6. The type of fit is, okay. Guys, how the H7 and S6 we can see. This is the H hole. Okay, this is one line here. And somewhere S is here, somewhere the S is here, okay. Then here this type of fit, this is the lower dimension, this is the upper dimension, and this lower dimension is greater than the upper dimension of shaft. This is the whole system, this is for hole, this is for shaft. And here the lower dimension of this hole is greater than higher dimension of shaft. Therefore, the answer is clearance fit is the correct answer. This is very easy question if you know the metrology. Next, ring gauges are used to measure. Ring gauges, guys, the plug gauges are there, ring gauges are there, and ring gauges are used to check the diameter, but not roundness. Okay, here you can see the many options, roundness but not outside diameter, both outside diameter and roundness, only external threads. No, this is not for the threads. The ring gauges are used to measure the outside diameter of shaft. Means in that shaft, that ring gauges is going to enter. Some ring light is there, in same way the ring gauges are there, that gauges are going to enter into that shaft. Okay, then outside diameter but not roundness is the correct answer. Yes, now in order to have interference fit, it is essential that the lower limit of shaft should be, what is the answer here? The lower limit of shaft should be in the interference fit. Yes, what is the case of interference fit? Just see. Yes, just see, this is the one case of hole. This is the case of shaft. Okay, here I am writing the hole, and here shaft. This is the lower dimension of shaft and this is the higher dimension of hole. Then the greater than upper limit of hole, that is the correct answer, option A. In order to have the interference speed, the essential that the lower limit of shaft, just see this is the lower limit of shaft, this is the lower limit of shaft, you can see it is lower limit of shaft is greater than higher limit of hole, in greater than upper limit of hole, that is the correct answer. Okay, now all the questions which I want to take, that all the questions are completed. Okay, it is very good revision for number of chapters here. I hope so you are studying well, and all the best for your exam. Thank you very much again for attending this session. Thank you very much.